Hey there, welcome back to the channel. My name's Chris, and today I want to talk to you a little bit more about Meadow. Before going on, I want to apologize a little bit for my voice. I'm getting over a cold, so my voice is a little bit messed up. I'm going to be sneezing, coughing, whatever. As I said, though, I want to talk about Meadow. What is Meadow exactly? A lot of times people think Meadow is hardware, right? So I've got a Meadow F7 piece of hardware here. That is the F7 Feather. We also have a Core Compute module that is on this board here. But that's Meadow hardware. That is not actually Meadow. When I think of Meadow as it's a stack of software. It is a whole bunch of software, almost all open source and completely free. And what is Meadow used for? That stack. It's used for doing IoT or embedded or whatever you want to call it, small hardware development or talking to hardware anyway from managed code, from .NET. Typically C#, but you could do VB.NET, you could do F#, any of the other languages as well. So I figured a good thing to do is to write a driver for some hardware and show that it works on multiple things, that it is truly cross-platform. We can move it from one piece of hardware to another as a host. We can use that peripheral and we can display data from it on different types of displays. This is not at all tied to that F7 hardware. And most of what you can do here is, well, beyond the cost of actual hardware, is free. And again, open source. So one of my coworkers actually put out a request for a driver for this piece of hardware here. This is the one from Adafruit, but this is the AMG 8833. Basically, it's a thermal camera. You can see what they've got is they've got the device here as a module, and then they're displaying the data on this small display. I figured we'll do something similar. To understand how this works, basically this camera is an 8x8 grid, so it's 64 pixels, and it will give you the temperature of each of those pixels. It's communicated with over I2C, so it's a two-wire communication bus. I've talked about I2C in the past. I won't go into the development of the driver. If you're interested, I could go back and create a video on how I created this driver specifically. I did do it for this project, and it took me about a half a day, I think, about 4 hours of development from the datasheet. This is the datasheet here. Very typical datasheet. It's got some electrical specs, but you can see here that it has 64 pixels, and you get back a temperature by reading somewhere down in here. There is a register, there we go, a register of the pixel temperatures, and it gets back data in degrees Celsius with quarter-degree resolution. Again, pretty straightforward. It also has some support for things like interrupts, where if a certain pixel goes over a temperature, it can send an interrupt. We're not going to worry about any of that. What I really want to do is show the driver for this piece of hardware working on multiple pieces of, I guess, host hardware and different operating systems, in fact, and doing the same thing, but even to different displays. So if you take a look, I've got that same module here. Now, to do the development, I could do this development on the F7 hardware. I don't like doing that because the deployment time to something like this F7 is very slow. It's embedded, right? In order to do any development, I have to write the code and then push it from my PC down to the hardware, and then, get the result via console or debug. I usually don't use the debugger even on that because the step time just tends to be slow. I prefer something a lot faster, something that is more modern in feel that I can do. So I want to do development directly on my Windows machine, right? So what I've done here is I got this FT232 extension module. This one is also from Adafruit. There are other ones. And so what I have is this shows up as a USB device, and then this gives us I2C, SPI, and GPIO. So we can run the I2C bus to this over USB. And we've got a driver that I wrote for that for Windows. So if we go take a look at the code for this, so again, it's this module here. This is an FT232. So the way that I use that in code is I just initialize and create this FT232. This false here is for which type of driver. Basically, false means I'm not using it for SPI. But once I have that peripheral, I can do the create I2C bus. This is the same as if we were doing this on an F7 platform where we do the device create I2C bus. Both of them return this interface I2C bus instance. And then I can take that bus and pass it to the AMG 8833. So basically I've created an I2C bus and I pass it into the peripheral. And you'll see that that ability right there is what provides this cross-platform ability. I then decided, of course, we need to have some sort of, visualization of this to make it at least interesting. So here I just used the micro layout library, and it's got a box control, which is just, as it sounds, it's a rectangle that will color. And I make 64 of them in an 8x8 grid. And then the screen and add it to that. Basically, this is just creating that 8x8 grid. And then I'm going to put it on the display. Again, the display here is abstracted out. So this WinForms display is an implementation of an iGraphics display. Meadow Foundation, again, open source and free, has a whole bunch of implementations of these. And we'll see a couple more of those here as I go through this. But this one is a WinForms window that provides that interface. So I've got a WinForms display. This is just going to create a window that is 480 by 320. The reason for that size will be apparent here in a few. But then I just create that 64 by 64 grid on it, and each one of the boxes is 40 pixels by 40 pixels. So if I then run this application, so here it is, running on my Windows machine, right? So here's the hardware. And up here is the display, this virtual display that is displaying those pixels. If we come back and look at the code, I'm going to move this display up here for you. If you look at the code, it's really, really simple. Basically, I just go, if it's, less than 20 degrees Celsius, 22, etc. I picked, half a dozen colors here at 2-degree increments. Again, this sensor has a 1/4 degree resolution, but that's all I needed. The reason that it's got white here in the very center is actually my down-facing camera produces some heat, and that's what's generating that. But if I pass my hand across this, you can see, and it's oriented slightly different. Let's see, I guess it's probably oriented this way. There we go. So if I run my hand over it, you can see the warm area of my hand going across, right? And it's it looks like the up-down orientation is probably wrong. That can be flipped, but the whole point is I've got I2C from my Windows machine running down to this hardware and running on this. This is all 100% open source software that you can freely download, right? And if I'm doing development on this, classic example here, I'm just going to put a breakpoint right here. Boom, I'm at my breakpoint, and I can step through this code just as if I'm doing any kind of development. So it's very, very, very fast to do this development. So great, I've got that working. I could actually take this hardware and build some sort of a box, put it in an enclosure and hook it up over USB and drive this from Windows and make some sort of a device, right? I don't need that Meadow F7 hardware. But if I wanted to put it into something that was more standalone, that didn't require a PC and could maybe run off of batteries, an F7 might be the ticket that I want to go with, right? It could provide that capability. So really what it's about is what is your end product, what type of hardware you would choose. So now let's say I get it all working on this hardware, and I want to move to this embedded hardware. So this is the Feather F7 Core Compute on a Project Lab. It's a little bit easier. I don't have to use a breadboard or these wires. I've got this quick connector here, and this already has a display. I don't remember that it's an ILI, I think 9314, something like that. But again, Meadow Foundation supports a whole ton of displays. So then I can just take all of this, yank these out, and I'm not going to use the FT232 anymore. I'm just going to go straight to the device. So I plug it in here. So we plug this into our sensor, and we'll turn it so we can see them both at the same time. And then let me pull up the code for this. So this is the code for the Windows sample. You can see, we create this WinForms display, and we get our I2C bus, in this case from the I/O expander. So on the Project Lab, what we do is we just use the I2C bus that is on that quick connect here and pass that bus into the same exact driver. Then I'm going to use the display, which is this display here, and pass that in to create the screen, which is, again, a 64 box array, and they are 40 by 40, and this display is 320 by 240, which is why I selected that before. The logic for doing the display, it's the exact same. In fact, this is just a copy and paste. So we are looking at the same. Now in this case, you can see I am doing a scale here, and the reason is I'm using the raw data from the sensor instead of the temperatures. It simply runs a little bit faster on an embedded processor. I could still do it with the temperature data, so it's identical code here, but I went with the raw data instead, simply because it gave me a little bit better performance. But now let's hook this up and run it. Again, really the same code. So if I plug that in, and it's up and running, again, you can see we've got this hotspot from the camera right above. But now, if I pass my hand over it, the color from this display is a lot better in person. It's really washed out here in this video, I think. Yeah, it's tough to see that that's yellow. Let's see if I can get... Doesn't look to be a lot better. But point is, you can see that I'm getting the same exact behavior. So I'm running really the same code here, getting the same kind of information over an I2C bus and putting it out on a display. So I used an interface. So I've got this display, which is an SPI-based display, or I had the WinForms-based display. I'm running on the F7, which is Meadow OS, which is a NUTX embedded microcontroller software OS running on this hardware. The other one was running Windows, right? So two completely separate types of architecture, two completely separate systems with different displays. Same input device, same hardware, same code. So that's pretty cool. But you go, okay, well, yeah, I can do Windows or I can do Meadow, but what if I don't really want to buy a Meadow device? I'm still, experimenting, and I've got, say, some Raspberry Pis laying around. Can I run it on Raspberry Pi? Yes, you can. I decided while I'm doing all of this, let's do that version as well. So I have, here is a Raspberry Pi W, or Raspberry Pi 0W2. That's a mouthful. I don't remember how much these are. These are pretty inexpensive. In fact, they're about the same, I think, as a Meadow F7 Feather. But these are pretty common. A lot of people have them laying around. Point being, though, that maybe you have this and You want to use it for some sort of testing or prototyping to get things figured out. Does this work? This is running a version of Debian Linux, I believe. I honestly don't remember. The nice thing about the Meadow stack is I've run it on Debian, I've run it on Ubuntu, I've run it on Red Hat, I've run it on CentOS. It doesn't really matter as long as you can run .NET. So that's one of the interesting things to point out. On the desktop, when it was running on Windows, I was running against the full .NET 8 runtime. It was not running mono or anything like that. It was running full .NET. When I moved it to the project lab, this is running with mono, a custom build from Wilderness Labs in order to run on a microcontroller. .NET 8 does not install on microcontrollers, so Wilderness Labs has built that. When we get to here, what are we going to run on? Well, I'm going to run on .NET 8 again. I'm not going to be running with mono or any custom thing, so any code, any modern application development will work on this. You can use all of your NuGet packages that you're familiar with. You can couple that with the stack of Meadow services that give you access to devices and, 200 and some odd peripheral drivers that are already developed right out of the box. So let's hook this up to our hardware. And let me find power for it. And so now I'll boot this up. At this point, you might be wondering, what are you going to use for a display? My original plan was to use this display to display it, to prove that it all worked with the same hardware. The reality is that in order to run this display, it requires 9 wires off of here, and then this plugs into a breadboard, and the display plugs into the breadboard. And if you've got any experience with that, oftentimes you get a little bit of a flakiness with one of these connections. At any rate, I couldn't get the display to work. The clock signal looked really ugly. And so I actually abandoned deciding to show it that way. Instead, I said, let's try to do a completely different display. And in fact, I wrote a display driver specifically for this project for this to show how flexible the Meadow stack is even on displays. So let's go take a look at that real quick because it is kind of interesting. So if we take a look at this display, it's an ASCII display. So basically I'm just taking the console, and a character position in the console is a pixel, so an interpretation of a pixel, and the brightness of the pixel depends on the character. So a space is going to be full black all the way over to an @ sign is full white, and these are the gradations in between. If you've been around for a long time, you may remember old school ASCII art where there were pictures made with nothing but ASCII characters. So it's kind of in that vein. So I just created a display. Again, this mimics the same interface or implements the same interface as that WinForms display and the one that we had seen on the project lab. But this is just going to the console and displaying it. And you can see it is, there are 90 lines of code here. It's not very complex. What it's doing primarily is, if given a color, it converts that to a grayscale, single byte grayscale, and then converts that to an index in that array of characters. So if it's got a grayscale of 0, it's going to give you this. A grayscale of 255 is going to give you this, and then proportional in between. And then all it does for that, effectively the pixel buffer, is this is just a 2-dimensional array for X and Y. And when it goes to display these, again, nothing rocket science going on here, but it just loops through the entire buffer No, this is not efficient. I wasn't building it to be efficient. There are a lot of things that you could do to make this better, but I was just trying to go with functionality to prove the concept. It walks through the entire array, sets the position, and then goes and gets the character based on what color it's supposed to be, and then writes that character to the screen. So it starts at the top, writes a row, and runs all the way down. And then it prints that out on the console. So we have a display that goes to a console. So let's fire up an SSH session over to this Raspberry Pi. You can see here, all I've done is copied over my application. I built it on the desktop. So if I come back and we look at the app itself, here's my Raspberry Pi sample. And again, you'll see this follows the same pattern, right? I create the I2C bus from the device, so that gets the I2C bus. Let's show you the device here again. So this gets the I2C bus from these pins that are connected to this sensor, passes that bus into the same exact driver for this AMG 8833, creates the layout, which is again a 64 box array that's 8 by 8. This time the size is a little bit different. What I did was I went 4 by 3, so 4 characters wide and 3 tall. That ends up fairly square in the console. And then the exact same thing we're doing, same exact colors based on temperature. This is, again, just a copy and paste from the other one. So now if we come over and we take a look at this and we run it, and here, let me just prove to you that this is just running standard.NET. You can see, got .NET 8 installed on this. All right, and so when we fire it up, you can see this is our grid. I probably could have gone another pixel or another character wide on a pixel. But here is that bright spot, which is the camera. And if I move my hand across, and again, the orientation is probably not right. So let's see if we can find it here. Oh, that's 180 out. There, see? So there's the warmth of my hand in the glorious, amazing graphics of ASCII. The point here, though, is that we've got embedded hardware written in C# that runs on Windows, runs on embedded Linux, standard Ubuntu. We've got it that runs on a microcontroller here, all using the same drivers. We can swap out the displays based on our need, but the core logic remains the same. That's what the power of Meadow is. It's not just that it can run on a microcontroller, which, to be clear, I think is pretty darn cool, but the fact that you can run it and prototype it on different things and move it up and down stack. You go, oh, well, I need a little bit more horsepower. Okay, well, come from this and move up to a Raspberry Pi, or maybe move up to a Jetson Nano, if you're doing like AI and ML. Or maybe you develop it on Windows and move it down to something like this. So Windows gives you the speed of development. Or you develop on a Linux desktop machine using VS Code and then move it down to a Pi. But then you run on the Pi for a while and decide, oh, well, I want to be low power. I want to run this on battery. So then I move to something like this. It gives you a lot of flexibility. Again, open source, free, 200 and some drivers that are open source for different peripherals. If there's a type of peripheral, it's probably supported. The stack for managing all of this is all there as well. So, yeah, go check it out. If you have any questions, comments, go ahead and leave a comment down below. If there are any other things that you would like to see, peripherals, how things work, go ahead and leave a comment. Otherwise, I'm just going to keep driving with these. I might talk about displays next, or go into a little bit more depth on this display driver, how it's being used. We could talk about the layout engine that I'm using for drawing this stuff, anything like that. At any rate, that's it for today. Thanks for watching.